Hello once again. As usual, I'm by the names of exercises teacher Modeste. So today's topic is about physics. So in our topic of today, physics, you are going to see what we call the law of conservation of energy. Law of conservation of energy. So usually we should have learned what we call potential energy and kinetic energy in order to understand better our lesson of today. So as usual, energy by its definition is defined as the ability of doing the work. So energy is the ability or capacity of doing work. So if the energy is the ability of doing work or capacity of doing work, so we have two kinds of energy that you are going to be taking care of when we are explaining about the law of conservation of energy. So we are going to take care about kinetic energy and potential energy. So by starting with kinetic energy as represented by letter EK is defined as the energy possessed by a moving object. So it is defined as the energy possessed by a moving object or body. So it is in the formula is given by EK, which is 1/2 mv squared. So this implies that kinetic energy is directly proportional with the mass of moving object and the square of the velocity of that moving object. So as it is written like this, means that it is half of mass times the velocity of our object, which is in motion. So potential energy, which is represented by PE, is defined as the energy possessed by object due to its position. But this position is in vertical direction, means that it is an upward motion from the ground. So mathematically, potential energy is represented by mgh, where m is the mass of our object, g is the acceleration due to gravity, and h is the height at which our object it is from the ground or other reference. So now we are going to see the law of conservation of energy. So our law of conservation of energy stated that in all energy conversion or transformation, energy is neither created or destroyed, but it may be converted from one form to another, but the total amount remains constant. So it is clear that the energy may be converted from one form to another, but the total amount of energy remains constant. So we may convert potential energy into kinetic energy, but the total amount will remain constant. Or we may convert from kinetic energy to potential energy, but the total amount will remain constant. So let us use a diagram to demonstrate our law of conservation of energy. So let us consider an object which is at a height from the ground. So let us consider that this is a ground. So our object which is in our height, it is going to be released fully downward. So this means that our object is going to fall down on the ground. So let us see how our object, how the energy will be converted according to the motion that's going to be done by our object. So our object, when it was here at our height, the potential energy at this point is maximum, where it is mgh. Let us suppose that our height here is initial height, and we have h final, the final height. So at the ground, height will be equal to 0, because at the ground, height will become 0. So here, as our object, it is at rest. This implies that kinetic energy here will be equal to 0, because here, this is because velocity will be equal to 0, because our object, it is not in motion, it is not moving. So when it starts moving, the potential energy will be converted into kinetic energy. So let us consider at this point. If it reaches at this point, so we will have potential energy, which is, suppose that here we have F, which is F2. We will have mg with height 2. So, and continue. So at the ground, we will have potential energy which will be equal to 0, because at the ground, height will be equal to 0. So here kinetic energy will be maximum. So it will be given by 1/2 mv power 2, mv square, where v is the velocity of our object at the ground. So here kinetic energy will be maximum here, where potential energy will be minimum, where it is equal to 0. So here potential energy will be maximum and kinetic energy will be 0. So here when we take a summation of potential energy and kinetic energy here, will be the same as the summation of potential energy at this point and kinetic energy. So this means that whenever the object falling from here up to here, the potential energy as if it is the maximum here, kinetic energy will be minimum, and when the kinetic energy will be maximum here, potential energy will be minimum. So this implies that when the kinetic energy increases, the potential energy decreases, and vice versa. So when the potential energy increases, kinetic energy decreases in order to obey the law of conservation of energy. So let us use an example. Let us have an object here which is falling down at the ground. So this is the ground where height is equal to 0. So we are going to find the potential energy at the different height and kinetic energy at different height. At the same time, also we calculate the summation of energy, which is the total amount of our energy. So let us suppose that we have our object which has 10 kilogram, where we have here height which is 10 meters. So we are going to find the potential energy at point where we have weight 80 meters, where we have 6 meters, 4 meters, 2 meters, and 0 meters. So at 10 meters, we will have potential energy, which is mg h, where g is the acceleration due to gravity. So let us assume that our g, that it is given by 10 meters per second square. So potential energy here will be given by our mass, which is 10 kilogram, times the g, which is 10 meters per second square, times the height, which is 10 meters. So our energy will be 10 times 10 times 10 times 10, which is 1,000 joules. So at this point, kinetic energy, as it is at rest, the velocity is given by 0. So kinetic energy is given by 0 joule. So when we take summation here, we will get 1,000. So energy total will be given by 1,000 joule plus 0 joule, which is 1,000 joule. So let us see also the potential energy at height, which is 80 meters. So potential energy here will be given by, also we'll take the mass, which is constant, because our body is falling down. So at 80 meters, we assume that our object reaches here where we have 80 meters from the ground. So we have here potential energy, which is also mass, which is 10 kilogram, times g, which is 10 meters per second square, also times height, which is 8. So the potential energy here will be given by 800 joule. So this implies that in order to have the total amount which will remain constant, the kinetic energy will be given by the total amount of energy we had here minus potential energy we have at this point where we have 80 meters. So our kinetic energy will be given by 1,000 minus 800 joule. So we have here 200 joule. So when we take summation of our energy, we have 200 joule plus 800 joule, which will be 1,000 joule. So when we consider the point where we have 6 meters, potential energy also will be given by mass of our body, which is 10 kilogram, times g, which is 10 meters per second square, times 6 meters. So also we have here 600 joule. So the kinetic energy at kinetic energy at 6 meters will be given by the total amount of energy we had here minus the potential energy obtained at these 6 meters. So kinetic energy will be given by 1000 joule minus our potential energy. So our kinetic energy will be 400 joule. So the energy total at 6 meters will be given by 600 joule plus 400 joule, and the total amount will remain constant where we have 1000 joule. So let us see also at 4 meters. At 4 meters also we will have potential energy, which is given by our mass of our object, which is 10 kilograms, times g, which is acceleration due to gravity, times the height where our object reaches, which is 4 meters. Then potential energy will be 400 joule. So kinetic energy here will be given by the total amount of our energy, the total amount we had here minus the potential energy we have at 4 meters. So the kinetic energy will be given by 1000 joule minus 400 joule. Then we have 600 joule. So the total energy here will be given by 600 joule plus 400 joule. Then our energy will, the total amount will remain constant. So we have 1000 joule. So here at 2 meters, potential energy will be given by also mgh, which is mass, which is 10 kilograms, times g, which is 10 meters per second square, times 2 meters. Then we have 200 joule. Also kinetic energy at 2 will be given by our total energy minus potential energy we have at 2 meters. So it is 1000 joule minus 200 joule, which is 800 joule. So here the total amount of energy will be given by 800 joule plus 200 joule, which is 1000 joule. So at 0, where we have 0 meter, potential energy, the potential energy where we have 0 meter will be given by mgh, where we have 10 kilograms of mass, times acceleration, which is 10 meters per second square, times height, which is 0, then we get 0 joule. So at this case, kinetic energy will be given by 1000 joule. 1000 joule minus 0 joule, which is 1000 joule. So the total amount at 0 will be given by 1000 joule plus 0 joule, then we will get 1000 joule. So from our law of conservation of energy, so it is clear that at where we have the maximum height, the potential energy was maximum where we have 1000 joule, and the kinetic energy was 0 joule where we have minimum kinetic energy. So the total amount remains 1000 joule. So at the point where you have 8 meters, the potential energy started to reduce or to decrease where kinetic energy started to increase. So this means that when the potential energy decreases, the kinetic energy increases. So from our exercises or example, it is clear that as the height decreases, potential energy also decrease. So when the potential energy was decreasing, also kinetic energy were increasing at the same time, so as to keep our total energy remains constant as our laws state. So from this example that you have demonstrated, it is clear that the law of conservation as it states, so the potential energy was being converted to kinetic energy, but the total amount remains constant. Where we have 1,000 joule at every point where our object reaches. So at the ground, now potential energy becomes 0, where kinetic energy becomes 1,000 joule. So this is the one example which shows that the law of conservation is obeyed, where the potential energy decreases while kinetic energy increases. So in order to keep our total amount remains constant. So thank you for attending my lesson of today. So next time we will use more examples and exercises in order to demonstrate our law of conservation of energy. So thank you very much.